evening and welcome to the next part of the lesson on Group 7 halogens. There are 5 halogens that we need to know: fluorine, chlorine, bromine, iodine, astatine. Halogens belong to Group 7 and therefore all 5 halogens consist of 7 valence electrons. The physical properties of halogens are as such. They are non-metals and they exist as diatomic molecules, for example like fluorine F2, Cl2, Br2, I2, At2. The halogens are also colored and each of them have their unique colors. Halogens in group 7 are extremely reactive. They also form -1 ions because they have 7 valence electrons, and by taking 1 electron they obtain a noble gas configuration. So what trends must I know for halogens? It is similar to group 1, the melting point. We must also know the reactivity, the density, and for halogens, we must also know the trend of color. So for melting point, as we go down the group, the halogen's melting point increases. That means fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid, so therefore we will expect that astatine will be a solid as well. Next, the reactivity of halogens decreases down the group. The most reactive halogen will be fluorine, while the least reactive halogen will be astatine. Finally, the density of halogens increases down the group. Iodine is a lot more dense than fluorine. Next, the color darkens, or we can say increase in intensity down the group. Fluorine is a pale yellow, while chlorine is a yellow-green gas. Bromine is a dark red liquid. Iodine is a black solid. So we will expect astatine to be also very dark in color. Finally, the reaction that we need to know about halogens is this special reaction known as the displacement reaction. In the displacement reaction, the more reactive halogen will displace the less reactive halogen from solution. Let me give you an example. Fluorine gas will displace chloride ion in solution to form fluoride ion in solution and chlorine gas. When we balance this equation, we can add a 2 here and we add a 2 here. What does this mean? It means that if I have a solution of a chloride, like for example, in my solution, I have sodium chloride, NaCl. If I were to bubble some fluorine gas, so fluorine gas in, the fluorine gas being more reactive than chlorine will displace the chloride ions out of the solution. This will eventually lead to the formation of fluoride ions, so no longer sodium chloride, we will get sodium fluoride, and although we are bubbling in fluorine gas, you will see the evolution of chlorine gas, which is a yellow-green gas. Let me give you another example. For example, if I would add in chlorine gas into a solution of sodium iodide, the chlorine being more reactive than iodine will displace the iodine to form sodium chloride solution, and iodine solid will come out. Again, we can balance this equation simply. So that means we will see a black solid appearing. So let me recap. There are 4 important sections that you need to know. Halogens are nonmetals that exist as diatomic molecules. Halogens are colored and are very reactive, forming -1 ions. The trends of halogens down the group is that the melting point increases from gas, gas, liquid, solid, solid at room temperature. The reactivity decreases, with fluorine being the most reactive and astatine being the least reactive. The density of halogens also increases down the group, fluorine being the least dense and astatine being the most dense. Finally, the color darkens as we go down the group, fluorine being a pale yellow, chlorine yellow-green, bromine a dark red liquid, iodine a black solid, and astatine should be a dark solid as well. The reaction that we need to know about halogens is known as the displacement reaction, in which the more reactive halogen will displace the lesser reactive halogen out of the solution. For example, if I were to bubble fluorine gas into a solution of sodium chloride, the fluorine gas will displace the chloride ion to form sodium fluoride solution and chlorine gas. If I were to bubble chlorine gas into sodium iodide, I will get sodium chloride and iodine solid because chlorine is more reactive than iodine. So to recap the trends that we have, halogen's melting point increases down the group. The reactivity of halogens decreases down the group. The density of halogens increases and the color increases. From this table, we can actually see that generally down the group, the trend is an increasing trend. However, for alkali metals, the melting point decreases, and halogens, the reactivity decreases. So these are the 2 important trends that we need to remember, and the rest of the trends actually increases. Thank you for listening to this lesson. Hope to hear from you soon.